Thank you for coming. Today we're going to talk about debugging innovation. My name is Ivan Pedrazas.
And I'm Johannes Großmann.
We both work in what we call Docker Labs, and today we're going to show you what we've been cooking. Let's talk about innovation. Many companies talk about innovation. The way that we do it at Docker is in two ways. We have quarterly hackathons. Every quarter we do an internal hackathon, 24 hours working on projects, and then we also have the Docker Labs. The Docker Labs, basically the engineers come and pitch ideas, and we help them to understand what is the value, the pain problem that they're fixing, and if we think that it's something solid, we give them the time and the space to do it. We basically remove them from the team that they're working to focus on solving the problem they want to focus without the constraints of the current product.
Let's talk about debugging. Debugging can mean a lot of things. Like you can debug your application, and you can set breakpoints in your IDE. If you're a web developer, debugging can mean fiddling with the inspect console in the browser. But today, let's talk about debugging containers. This can be quite tricky and hard. There are a lot of things you need to know to get a shell into the container. And the other tricky end of this is the tools in the container. In a lot of cases, the things you need are missing. So it can be quite frustrating.
Yeah, usually what happens when you have to debug applications inside of a container is the experience is not great. Right? You need to know quite a lot about the application and the container. Right? And people usually make comments about being frustrated and lost, and that they have to do a lot of things that they don't want to do because I just want to debug my application. So it is challenging, right? The fundamentals of innovation is challenging the status quo of how we do things and trying to think outside the box a little bit. The other thing is this relentless desire of making things better. Right? It's like, is it good? Can it be better? Can we make your life easier?
So this slide kind of reflects the current situation when you have to debug with Docker exec. And I believe those who yesterday saw the Ivan in the keynote remember when he tried like he got a shell in the container and then tried to use Vim. It's not there. You try to use Nano. It's not there. Then you check for HTOP. So a lot of tools that you would want to use when you want to debug containers, they aren't there.
How many of you have you used Docker exec and enjoyed?
Oh, there's one. Oh, hand is down, so maybe not.
We need to talk.
Okay, we accept that.
That's the issue, right? Like we have to do it, and it's painful most of the time, right? So carry on.
Yeah, so to sum it up, user experience is not great. And that's why we are here today, because we thought, well, does it have to be that way? And the answer is no. There are things we can do to improve. And let's, can we switch to the other monitor, please? Yeah, so what we have done in the past 6 months or so is create an extension of a tool that will help with all this. If you go to the Docker Desktop Extension Marketplace and type debug, you will see this thingy, Docker Labs Debug Tools. In this case, we have it installed already. If you haven't, it looks like this. You click Install, and then you get this new tab. So this tab basically is like the README, and it also installs a new tool in the background. Here in the top right corner, you can see it has now installed. And there are lots of examples here. We will go into details later. But you will get a new tool that will help you with like the debugging thing. So if we type now which DLD, yeah. So this is the tool we now get installed and which does the magic of debugging that we are going to talk about. Can we switch back? Thanks.
So we're using an extension. The story of why we're using an extension is kind of like a side effect of having to talk with the captains. Let me go back for a second. So we started in labs internally, and then we talked with the engineers at Docker. They were very happy. And then we had, am I going?
Yeah, it's 3 slides later, but it's
Sorry.
okay.
This is what happens when you don't sleep and drink too much coffee, and then I forget things. So we have the extension. With the extension, as I said in the keynote, we do not run debug. We just install the things. Right? So like debugging applications, easy. Debugging application containers, not so easy. Like, do you use slim containers, distroless and this kind of containers? Why not? Because debugging is hard.
Yeah, so beginning of this year, we started to run a labs project on that. In detail, this meant I was given 4 weeks to build a POC and show to people that the pain we all agreed on before is like a real thing that Docker should spend time on. And I did that and showed it to people internally at Docker. Here we have a quote from Chris Markey. So people were quite excited about it. Some people said that should have been in Docker for way long. And we should keep working on this.
Yeah, so that's basically what we do in one of the labs projects. We validate the assumption, we build something, more or less successful. We get internal feedback, and then things happen, right? And in the case of the debug, what happened is that we used to call this gremlin. So if you're a captain and you remember the conversation we had, we used to call gremlin. But there's a company called Gremlin, and then they were not very happy with us having something called gremlin. So our lawyers and their lawyers had some kind of conversations, and it's like, we're going to change the name. The other thing that happened is that we had a repo we had to make private, which makes things a little bit tricky when you want to share your stuff, right? And then the solution was to create the extension. And creating the extension came with a few surprises.
Yeah, so the challenge is to make it accessible. One thing before we went to the extension was there was a hackathon coming up in Docker. So we had it in a repo, and we thought, well, just give it to people internally and let them clone the repo. Then we don't have the private or public issue, and they can just compile it and test it. And this was like the first moment where we hoped to get more people to try it. So I was very excited for this moment to happen, and was sitting for Slack and waiting for messages or feedback to come in. But nothing happened. No single response did we get from this.
Docker engineers that were in the hackathon and did not try it? No.
But 3 people cloned the repo, so and we got happy emojis. So people still were excited. That was clear, but still we had to do it differently. So the first thing was obvious, build a CI/CD pipeline and create the binaries automatically. But this doesn't help with the distribution thing. And that's when we got the idea with the extensions. With the extensions, you get all these things for free.
But Johannes is not saying this. When I said, hey, Johannes, what if we create an extension? And he's like, we cannot debug an extension. I said, no, I know.
Yeah, it's quite a flip you need, a switch you need to do in your head, because when you initially think about extension, you think about the UI tab, and putting in my mic on? Yeah.
Of course.
A binary that would be used from the CLI. So yeah, it's the marketplace functionality, installation metrics, and you can run binaries on the host. It's not the topmost thing they are advertising, but it's there.
I think it's something that is worth noting. It's a tool that allows you to distribute. Right? It's a distribution channel. And what we did was basically, okay, let's take it to the core and then distribute our binaries. And, well, it was a really good exercise.
Yeah, this is great, really great. But the thing is, what you actually wanted to do is like get your POC into people's hand. But what you're now doing is like building a React UI for the extension tab. You now need to properly document it. You need to make this all cross-platform. Then due to some limitations, you need to write an installer to get the actual POC binary at the proper location, and so on and so on. So you end up spending like 6 weeks only doing this and still haven't added any feature. So yeah, like, it was like this.
No, it was like, come on, do it.
Okay,
It wasn't
he
that
wants me.
call, but like, come on, do it. Like,
He wants me to do it, but yeah, like, no, like, I was pissed. Let's be honest. So, I didn't like it at first, but yeah, like, at the end, it was like a very good thing to do. So,
the user experience that we have with the extension is great, right? How many of you have to distribute binaries? Like, who is in an infra team that has to put binaries in the machines of teams and things like that? One. So, like, how much friction do you get when you try to write the document? Like, this is your runbook. This is what you have to do to run my tool. Is it a nice experience? It's hard, right? Like, and that's the thing with the extension. We got what Johannes was saying, like the updates. We know if it's installed. Like the user can go there and say, oh, this is installed, or it's not installed, or it's broken, like my machine. Right? Like the user experience got really, really nice. But it's true, you have to do this, right? You have to write the UI, you have to do the test, and so on. But it's worth it.
yeah. So let's jump into it and let's show it. Can we switch to the other laptop, please?
This is not Johannes and me fighting, by the way.
Can we switch? Thank you. Yeah, so let's run an Nginx container. Dash D, dash name, my app. Yeah, so let's at first do a recap and use the Docker exec to get into it. I think that's it, is it? Yeah, well, here it starts. First sorry, can I, yeah. What am I missing?
Yeah, what do you want?
Oh, yeah, my shell. Yeah.
He is your lack as well. No, but we all have been here.
But that's like the thing, like the pain you have with with this long command, and then you're there, and like the things we would want to use, they aren't there. So.
Hold on. Well, I'm not sure about the htop thing. Do you run htop in the container to see if things? Yeah.
I do.
Really?
Yeah.
Why?
To see what it does, and that it does something, to have proof. I don't trust it. Yeah, so let's do the same with DLD. With DLD, first the command becomes like more straight. It directly tells you, I get a shell in this thing. And then you get here. So this is like some intro message to tell you where you are. And if we now do like ls, we see things are there. And if you don't trust like me and run htop, we see there are all the Nginx worker processes. So yeah, like this is already like way better. And if we want to check if we can use vim, what's the directory?
Nginx.
I can never remember.
HTML.
Yeah.
Like there's autocomplete now, which.
Yeah, you can have tab completion. You also get like history, like if you use the arrow up and arrow down key. You get all this, which otherwise is like pain.
The other thing is that you can choose your shell. Okay?
Yeah, that's the next thing I was going to show. So with the Nginx, I pointed it to bash, but you might wonder, well, what shell are we actually getting here? So we can do like this. It says Z shell because Ivan apparently is using Z shell on his machine. So the first thing we do is like try to detect which kind of shell you're using. and we support Z-shell, bash, and fish. But you can also do it how do you have history here? The other way, set it explicitly. You can use like shell, and then let's use fish, and let's get into this thing again. Yeah, like it looks the same because we've configured it to look the same, but if you now do like tab completion, you get this nice tab completion that fish ships out of the box. Let's demo another thing. Like before we talked about the tools you would want to use, they often are like missing. So we saw Vim is here already, and the same goes for Nano, for example. But let's think about something that isn't there. What you can do in this case is like run the install command and just edit. I think it's, yeah. So this thing is based on Nix. So anything that exists in the Nix universe, you can basically get there.
Like Pokemon or anything?
Yes, maybe. Yeah, so now it has installed tree, and we can use tree, I think, like this, yeah. And you can remove it later. Like, at some point, marketing reached out to us when they wanted to advertise and ask, but what's like the list? Like, what things do developers get? And I said, well, like, I can give you a list. Like, they wanted me to give like an explicit list, but it's like 18,000 packages in the Nix universe. Like, if you want to print this, you can, but.
Does the list have space or tabs?
Oh, I don't know. But yeah, like, you get the point. Like, there are like a lot of things you can use from this.
Okay.
Yeah, let's get back to the slides then. Can we switch?
Good. So, excellent. Now we have debugging application in containers. Done. Next. Slim containers. Why is this important? Right? From the security point of view, we just put the application on the dependencies, but we're reducing the attack surface. Why we don't do it? Because if you reduce the attack surface, when something goes wrong, it's very painful and I cannot fix it. And you know, I'm the one who has to fix these things, so I will make my life easy. So a lot of people use Alpine instead of Scratch, mainly because they need to have a way of interacting with what we have there. Right?
Yeah, this is kind of the equivalent from the previous slide for debugging Slim containers. Like, with Slim containers, nothing is there. Like, there's no shell, all the tools are removed, because that basically is like the definition of Slim containers. So with Slim containers, I found this a while ago on Reddit. Like, this is how debugging feels, at least to me, with Slim containers.
You're a detective, the victim, or the murderer?
Yes.
Excellent. Well, what happened? Okay, so debugging in Slim containers is the same as debugging containers. You have seen, like, it doesn't matter anymore. Right? And for us, this is great in the sense that now you can use Scratch and put just your binaries there and be done with it. Because with Docker debug, you can do what you want to do, right? Excellent. So, enables best practices and increases security. Because people tend to do this, you know, putting too much everywhere, just in case. But this was the just in case.
Yeah, like this basically illustrates the value. Like from a technical perspective, there's nothing really fancy we are doing. Like one could have done this way earlier. But it's about like the user value it brings, that you now no longer need to worry like about all the tools you would want to have potentially, but can focus only on the thing, like building your app.
Yeah. So we can do more things. We can do debug in a remote machine. So if you're running Compose in one of your VMs and the container crashes, you can jump from your machine doing the DLD shell to the host, right? I don't know if I have internet, but I can show you.
Can we switch?
DLD shell. This was super slow yesterday. Let's see what happens. So I'm trying to debug a Mongo container that is currently in my home lab at home through Tailscale. So it works. So now I'm in the container in my house in England, and we can do something like, I know it has crashed. This is a container that is not running. So what I can do is to call this function called Entrypoint, and Entrypoint is going to try to do a few checks. And it's telling me that a few things are run and it is okay. Still the container does not run. And this is what we run when we execute the container. So I'm going to run it again. And what you can see is that my machine is a bit cheap, so it's one of these nodes, so I don't have the right CPU to run Mongo. Now I know that I will not be able to run Mongo in this machine unless I do something, right? The whole idea that we have with Docker Debug is trying to improve the usability. The way that you interact with these containers is all the same. Same thing with the entry point, all these high-level functions. What we want to do is, when you come in, try to give you as much information as possible, so you don't have to spend hours, minutes. I spend hours, I spend seconds, but it's because I have time.
But let's not stop with containers. Let's also try to take images into account. With Docker commands, you can debug images, like you can look inside of them, but it's like this, like imagine you want to go somewhere. What you want to do is like take your car and then drive wherever you want to go. But with Docker commands, it's like you get the pieces and you need to assemble it yourself. It's like you can use these commands, like they're not made up, or like the command lines on the slide, and it will show you all the files in an image. But nobody like remembers that or like would say that this is like a handy thing to do. So with DLD, debugging images or like getting a shell into them is like the same as getting a shell into a container. Can we switch back, please? Is this locally, right?
Yeah.
Okay. Thank you. So before we were running an Nginx container, and we're like getting a shell into the container. Now what we are going to do is use the same thing to get a shell into the Nginx image. Yeah, so it's the same thing. Like you can use the same command, and it doesn't matter if it's like a container or an image. It feels the same. Still, there are like some differences. For example, if we run hjob, we don't see anything running because, well, it's an image, not a container. We can also look around and like see the files. We can open them. We can even do changes. For example, if we go into the home folder, we can create something, and it will be there. But it's like a sandbox environment. So every change you're going to do here, if you leave the shell, it will be discarded, and at no point will like modify the actual image.
Yeah, don't use it to modify your images. This is like...
Yeah, like you cannot like work there and in there and build images from there.
This is, for example, if you have an image and it's not working and you need to change the configuration, then you can do it at that point. Test the configuration that is right. Once you have it, do a Docker build and create a new image.
Yeah, and then one more example I wanted to point out, like Ivan already showed it, the Entrypoint command. Like in other languages, when you write code, ideally the code is like very expressive and tells you what it does. But in the Docker file, we have the cmd and the Entrypoint command. And well, they do kind of the same thing, but they are different. And for both, there are like two ways to use them. Like you can put the stuff in the brackets, or you can put your stuff directly in the Docker file, and it can be quite confusing. Well, there are docs, but it's like 3 pages to read, only to understand this thing. And this is where the Entrypoint command can be quite handy. Yeah, we have seen this before. Like, it explains you how things work. If you don't want to read this, you can just do --print, and you will get the command that is executed by default if you run a container from this image. And we can also do some simple checks when we run Entrypoint --lint. For example, that the binary of the command or the file actually exists, and that you are not like doing very silly mistake like mixing different types of syntaxes of the entry point and the CMD in the Docker file. Let's get back to this slide.
Do we check the architecture?
Not yet. Like, there are a couple of more things. Like, right now it's still experimental and distributed as an extension. But one of the future things we want to do is get this into Docker core. And there are still like a lot of things on our list to add to this. For example, one issue people keep running into is that architecture doesn't match of the image they are using and
the binary
and of their host. Like, for example, I discovered on Mac, you can actually run Go binaries that have the wrong architecture. It will work, surprisingly, except if you want to do like certain system calls, and then it fails. So like, there can be very subtle errors that can be super annoying. And what we are going to add here is like an automatic check to detect this directly. And the other thing we are going to add is, for example, to directly in the entry message tell you which distribution your image is from if you are using like one of the Alpine, Ubuntu, or Debian images, or not if it's from scratch.
Yeah, I don't know if this does. So one of the things that I did, I wanted to know, for example, how many attributes can you, how many properties can you modify in a WordPress? So instead of running the container and go and check, what I've done is to do DLD in the WordPress image, and I run this command, and it told me what I wanted to do. Right? Like for this kind of validations, debugging images is great. Let's switch to the other one.
Yeah. Can we get back to the slides, please? Thank you. Yeah, let's talk about how things work. Like, what are we actually doing?
Breaking cars. So this is a little bit of the example that I gave yesterday about cooking, but with cars. So if you don't cook, but you drive, this example is going to be very good. You're driving, your car breaks down, and you have to fix it with the tools that you have in your car. If you're like me, you don't have any tools, and then you cry. With Docker Debug, what we do is to get this car and put it in the garage with all the tools and things that, coffee machine, everything that you need.
Yeah, so on a technical level, what we are using is, when you run a container, on a technical level, it essentially is like a running process, but with some running in some special context that isolates it from the host machine. And this is what the engine creates when you start a container. So what we are doing is running a second container, but instead of creating a new isolation context, we tell the engine to reuse the one of your target container. With this way, we directly see like the namespaces of the container, like the PID, the mount, and the network namespace, which means, in case you are not that deep in this Linux things, you can now see the process of the container, its mount, and its network traffic. And you can also see the files if you go to this proc PID root directory. So this is like the first part of the equation, or like the things we need.
But they all know that. They read the kernel manual to go to bed, so it's fine. It's fine. Carry on.
Yeah, like when we created the slides, we kind of were on the fence, like how deep we should go here. Anyway, like the next thing we want to do is get the tools in there. And there are a couple of things we need to be careful with. The first thing is we don't want to change at any point the actual container. So we don't want to put any mounts in there or copy any stuff in there. So we're using something like with the overlay FS that we put stuff on top of the container file system. And then this other file system, we add the tools in. Unfortunately, there are some other like catches. If you want to get static compiled binaries in there, things are fine and easy. But like eventually, you would want to use some tool that is dynamically linked. And that means it has some implicit dependency of something that lives in the lib folder. And this can lead to like very annoying merge conflicts that you're gonna not be able to resolve. So instead of fiddling with this, we turn to Nix, which is quite nice because everything is packed in this Nix folder that you can also see on the slide. So from a high level, it looks like this, and at the end, you get like this file system. And the third piece in the equation is like running the shell process and doing some PTY forwarding magic to get it on the host, because we are still running like in the Docker desktop VM. And that's basically it.
But why did you put my pin in the container?
Again, sorry?
The credit card pin, like you put my pin in here. What did you Sorry. It's been a long day. Okay, so what's next? What's next in store? I said yesterday, so I'm not going to do anything. Kubernetes, hey, excellent. Because it's about the experience, right? Like I want to debug my containers the same way, and the fact that you're running the container in your machine or in my machine or in the cluster should be completely irrelevant.
Yeah, so that's what I'm like currently working on when I get back from DockerCon, like kubectl shell, and it will give you like the same experience. Like on a technical level, things actually are a bit different, but the experience will be the same. Then there's like some cleanup and technical fix stuff to do, but on say the next month's scale or like roadmap thingy, the bigger goal is to get this into Docker Desktop and make it like a proper Docker command, so that you don't necessarily need
Proper command, yeah.
Well, people kept asking for this. Like we'll still keep the extension. It's like the nightly version of this, or like experimental track, but some stable part of this we're gonna put into Docker Desktop.
Yeah. So, ta-da! It took me a while to do all these images. It's just like this is so. Yeah, this is what we hope. We're here. We could. This thing works in his machine. Nothing works in my machine, but in theory it should work. And once we manage to release it, everybody will be happy. So I think that with this, we're done. Thank you. Do you have questions? Do you have questions, suggestions? How many of you use extensions?
I've got some hands.
Ah. Yes.
George, are you happy with the answer from today? You bugged me yesterday quite a lot about like how things work. Like, are you satisfied?
I want to see the performance. How was the performance? How fast is that merge?
The merge thing.
Hold on. You need a microphone. Introduce yourself.
Yeah, I'm Jorge Arteiro, I'm a Docker captain, and yeah, Esther was asking exactly that. And I guess it was a mounting, and yeah, how fast is that meshing, how long it takes, and is that going to be a problem or not?
I don't know precisely. If you want to like check yourself, the tool we are using is mergerfs. Like, ideally, we would use overlayfs, which already comes with Docker Desktop and is baked into Linux kernel. But the issue with overlayfs is we cannot write to lower layers, and we want to do that. Like, if you attach to a running container, you still want to be able to modify its file system, which is on like the lower layer. But we also want to write something on the upper layer where, for example, the file for the shell history lives. So for that, we are using mergerfs, which is the tool, and they have like a well-documented GitHub page, and I believe they have stats and like document these things. But it's like a, how to say, userfs, a fuse. So it probably is like slower than normal mounts, I guess.
Yeah, fastfs, not ready yet. Just good. Any other questions? Yes.
I haven't used the extension yet, but I'm wondering, is there any persistence? Like if you want a tool and you want to keep using it in subsequent debug sessions, does it bring your current shell tools into the container, or does it just keep like a list of basic tools?
Not yet. Like, it's one of the ideas we initially had, like somehow get the list of the tools the user already has on his machine.
And the aliases?
Sorry?
My aliases?
Yeah, but we could do that. Like, if you think we should do this, please go to the, like, on the roadmap, we have an issue and make a feature request. Like, this goes for all the things. If there are things...
He wants this. He is telling you. He wants this. I'll do it for you. Don't worry. You can buy it.
Like, it's one of the things for later. One of the, like, more on the shorter term things is like, there's a thing called devbox. Like, if you have like using Nix already on your host with for example, devbox or directly, then it would be easy, and we could do that directly. But it's not like on the direct.
Are you using Nix? Anyone is using Nix? No? Good. Then you cannot do it.
Yeah, could you explain how you would use a tool to attach onto a host with multiple running containers again? So how would that work?
I think, you mean this one? Sorry, I cannot see you.
Yeah, like if you have multiple containers running on the instance, and then if you use a tool to attach the DLD session.
So.
But that's what happens here, right?
Yes. I'm thinking how to explain. Like, usually each container has like its own like isolated context, and they usually get like PID1 within this context. Let me think. Yeah, so what we are doing is we get the context, and then you can do like Docker inspect to get the PID, and then we know where we need, like which context we need to get into. Does that make sense to you?
Yeah, because if you're running the containers on like Amazon's EC2, then...
You're talking about a Kubernetes case. Like, this is for locally and remote Docker. With Kubernetes?
I think that it's just an EC2 machine.
EC2 machine is what Docker containers running. Yeah, or just SSHing it, yeah.
So are you running like a remote Docker in these?
Yep.
Then it's the same. Like, it will pull an image into your machine and run a container. And the container will be like the one that is labeled sidecar in this thing.
Yeah, that makes sense.
And like, if you type exit at the end, it will also tell you how to clean up and because now there's like an image and maybe you want to remove it. Like by default, we keep it there because it takes a bit and we don't know like if you want to shell into again or not.
Any other questions? Then we can go. Thank you for coming.
Thank you.